Hi, I'm Bill Shaw from Cope Master. This tutorial is going to be about understanding the cope joint. Let's look at this first to understand why the cope joint is such a good joint versus a miter joint. We could do a whole video on just the differences between who likes the cope, who likes the miter. But here is a box that I made that has a movable wall. So we have two walls in the ceiling.
And I have this wall movable. And if you can see here, when it's lined up with this line, we're at 90 degrees. And if we slide it all the way over, this is 92 degrees over square, and this is 88 degrees, and it's under square. And want to show how well a cope works with the walls being out of square. So here at 90 degrees, you see the cope fits pretty well. Now if I go to 92 degrees, you can see the cope still fits, and we can rotate it and make the joint fit good even at full 92 degrees. And then if we go to 88 degrees, we can also rotate the joint and make it fit.
And we look at the line, we're lined up at 90 degrees and the cope joint fits fine. Now if we move the wall to 88 degrees, you can see the cope still fits. And if we go to 92 degrees, we need to move the crown a little bit, snug it up, and you can see the cope still fits pretty well. Now we can even throw the ceiling out of square to the wall by 1/8 of an inch. And now again we're at 90 degrees and the cope still fits, 88 degrees, and 92 degrees. So you can see how forgiving the cope joint is. Even though the wall's out of square and the ceiling's out, the cope joint still fits in all of those situations. So that's the reason why we want a cope, is because the cope is such a forgiving joint. Now, when we were back at our movable wall and ceiling, we were going 2 degrees under square and over square. And if you do the math, a 2 degree out of square over a 12-foot wall is 5 inches out of square. So can you imagine your room being 5 inches out? That's huge. So most corners aren't even 2 degrees out. There might be a localized compound buildup, joint compound, or a stud might be bowed, throwing things out. But most corners aren't 2 degrees out. So you can see that the cope is so forgiving that it's going to work on any corner in the house, whether it's new construction, old construction with plaster walls, it's going to work. So most carpenters, any competent carpenter can make any cope fit, any molding that is technically copeable. Some crowns are technically uncopable, and we might do a video on that. But anybody can make the cope fit, whether it's a 6 or 7 inch crown. They might have to recut the miter, they might have to give it more back clearance, but they'll get it to fit and can make it fit perfect. But what we want to do is understand how the cope joint works. So we all know that the cope joint starts with a miter cut. The miter cut is always a 45-degree cut, whether it's a baseboard, chair rail, crown molding, frieze board, anything that we're going to cope, we put a 45-degree cut on. This generates our cope line that we're going to follow with whatever method we're going to cope, whether you're using a hand coping saw, a jigsaw, the Cope Master, it doesn't matter. We're going to be following this cope line that the miter saw cut generated.
We start our cope with a miter cut because it generates our cope line. So not only does it generate the cope line, but it sets the depth of our cope. This is a 45-degree cut that we did on our chop saw. And remember, a 45-degree cut, both sides are equal, so this molding is 11/16 thick. This line, this base of the triangle, is 11/16. So the depth of our cope is going to be 11/16 if we cut right up to this line. So here I just cut right up to the cope line, only this deep. So I left the long point on the miter. And I want to show you that here, it's looking like it's fitting. Cope line is mating up with the piece, and if we look on the back, we can see that the miter cut is that depth. It's right to the back of the molding. Okay? So if we take it this way and we look at it, the miter cut, that long point, is right to the back of the molding. So if we removed the rest of this material right up to the cope line, we would wind up with this, and it's going to go and fit right in. It's the right depth and everything's going to fit. We start all our copes with a miter cut because that generates our cope line. And I'm sure you've all cut a piece of baseboard like this and noticed that the cut wasn't square. You don't need to put a square here to see how far out of square this is. It's really easy to see with the naked eye.
And you would recut the miter cut right away because you could see it's out and you're not going to use it. The same thing happens when you cut the crown molding, that the miter cut isn't perfect, but you can't see that it's not perfect. You're assuming that it is. And you might assume that your baseboard cut's correct, but when you look at it, you know it isn't. Well, you can't see that the miter cut is off on this crown molding. So we're going to discuss how to make sure the miter cut is perfect. So we're first going to do that with this solid crown, which is really the same as a chair rail or a piece of base. It sits in your saw flat up against the fence and up against the table, and all we're doing is putting a 45 miter cut on. Okay? Now the interesting thing when you do a 45 miter cut is, if you remember from high school math, a 45-degree right triangle, both sides are equal. So when we go to make this miter cut on this solid crown, here's a triangle representing our 45-degree miter cut. So this molding is 1 3/8 thick. When we put this miter cut on it, this base of the triangle is also 1 3/8. So it's 1 3/8 thick, it's 1 3/8 on the base of this triangle. So that makes the depth of our cope 1 3/8. And if you think about it, we're trying to cope into this piece that's 1 3/8 thick. So the cope that's going to go into that piece needs to be 1 3/8 deep. Only makes sense. And that 45-degree cut is what makes it perfect. That's what makes it work.
It's 1 3/8 thick, and we put our miter cut on it, which generated our nice high contrast cope line with the black paint. Now we wanted to make sure that this is the perfect cut, so we want to measure it. And if we look here, we have our triangle. This is a 45-degree, so this triangle should be 1 3/8 by 1 3/8. And if we measure it, we can see that it is 1 3/8 by 1 3/8. So we know this is a perfect miter cut for this piece of crown. Now, if we take this same crown and we take it as a sprung crown, you can see that this is the exact same profile. And it has the same ceiling projection. And if we take this crown and we put it in our square here, we can see that it has the same ceiling projection, 1 3/8. So what I want you to think about is that the ceiling projection of this sprung crown is the same as the thickness if it was a solid crown. So think of your ceiling projection as the thickness of the molding if it was a solid piece.
Here's a little board that I made up that has that same solid crown, and I have 3 different miter cuts on it.
And here we see the triangle created by the miter cut, and you can see that this one's not 45. These two legs of the triangle aren't equal. So if I cope to this line, the cope's going to be too deep, and we're going to wind up with a cope that's open on the top.
And how many times have you done a crown molding and had the cope open on the top?
This middle one, this is a perfect 45-degree cut. It's 1 3/8 deep. This miter cut comes back 1 3/8. When we cope to this line, the cope's going to fit perfect. And this bottom one, the miter cut is short. This is only 1 1/8. It's 1 3/8 deep. So the miter cut is short. The cope's going to wind up short and it's going to be open on the bottom.
So we can see how important the miter cut is. It needs to generate the right cope line at the right depth, so the cope is the right depth to fit into our mold.
All right, so we need to measure the ceiling projection of our crown. You want to make sure that you start with a flat piece that's not cupped, okay, because that's going to throw your measurement off. And then we want to cut a small thin piece like this because it's much easier to hold into the square. So I like to get the bedding foot on the wall and then slide the crown up till it touches, okay? And now we're reading 3 1/8 inches. I just want you to notice that we can shift this. We could make this 3 1/16 or 3 3/16 without much trouble. But you want to pick a ceiling projection and stick with it. So we're going to use 3 1/8 for this crown.
When I said it was easy to see the miter cut was off on our baseboard, because it's easy to see that that vertical line is out.
The same thing happens with your crown cut, but you can't see that it's off. And here I have 3 pieces of crown, same crown, and they were all cut at 45 degrees, but only one of the cuts is correct for our cope line.
And I do this at trade shows, and I ask carpenters to pick which molding has the proper cut. They're not all the same, even though they were all cut at 45 degrees. So the carpenter is going to look at the molding and he's going to try to figure out which one's off. And he has a 1 in 3 chance of picking the right one. But the chance of getting the right one and telling me if it's perfect, he can't do. He can tell me which one he thinks is right, but he can't tell me if it's perfect or not.
So by looking at these, there are some telltale signs that people use. They want to see if this is square or if this is square. But you know, this is such a small little piece here, it's hard to tell if it's perfectly square. And this doesn't necessarily have to be square if this line isn't plumb to the floor. If this isn't plumb the way the architect drew it, then this line isn't going to have to be square. So if you look at these 3, you might be able to pick one that's closest, but you still can't tell me if it's perfect. So if you remember this crown, it had a ceiling projection of 3 1/8 inches. Okay, so now, since we can't tell exactly which one's the best cut, we want to measure to make sure we get the right cut. So this first one, we're going to slide in here until we hit the long point and measure. And you can see this is about 3 3/8, so it's a 1/4 inch too long. This one is about 2 7/8, so this is a 1/4 inch too short. And this one is 3 1/8, so this is the perfect cut. And you can't tell that this is a 1/4 inch too short and this is a 1/4 inch too long just by looking at it. So you have to measure to make sure it's the right cut.
Okay, so we know we need to make a perfect miter cut so we have the correct depth for our cope. So let's go over to the miter saw and see what we can do. Now remember, the ceiling projection, we can vary it because most moldings have an undercut. This is exaggerated quite a bit just to show, but most manufacturers will put an undercut on the bedding foot so the points of the molding are going to hit the wall and the ceiling before the back does. So when we take this crown, we could actually slide it up the wall a little bit and increase the ceiling projection, or slide it down a little bit if this end was undercut. And we can vary the ceiling projection a little bit, but what you want to do is pick a ceiling projection and stick with it. So on this particular molding, it's 3 1/8 inches. So what I do with my miter box is I'm going to take a piece of plywood and I'm going to rip it to whatever the ceiling projection was, in this case 3 1/8 inches. Then I'm going to take it over to my chop saw, I'm going to put it against the fence, and then I'm going to take an auxiliary fence, crown stop fence, so we can put our gauge block, our 3 1/8 inch ceiling projection gauge block up against the fence, put our stop up against it, and then screw it in place. So now we know that our crown stop is 3 1/8 inches away from the fence and parallel. And as we drop our crown molding in, it's going to be held at the correct ceiling projection, which is 3 1/8 inches. Anytime we drop this in here, it's going to be 3 1/8 inches away from the fence. Now remember, we're dropping this in upside down and backwards. So we're going to put a left cope on this piece. So this is the left end of the board. So we're going to take this and we're going to flip it upside down. And now the left end is now on the right end. So that's why we call it upside down and backwards. We're going to drop it in. Now all miter cuts for copes are at 45 degrees. So bring the saw over to your stop and just proceed with your cut. Okay? Now after we do the cut, what we want to do is measure it again to make sure that the cut is the proper cut, which is 3 1/8 inches. Now if we remember from our high school math why this is working, is here's our 45-degree right triangle, and if we put it here on the saw, we see we're coming out 3 1/8 in this case, or 5 inches on this piece, and we're going to put a 45-degree cut on it, and we're going to go down the molding the same amount. Okay, so we're out 3 1/8. The miter cut is going to go down the molding 3 1/8 inches. Now sometimes this is a little hard to visualize because it's a sprung molding, but if we look at this solid crown, there's no difference between the solid crown, or if I take this same molding and I cut off the back and make it a sprung crown, the ceiling projection is the same. It's 3 1/8 inches. All we're doing by having a sprung crown is we're using less wood. You can see this is coming out of a piece of 4/4, this is coming out of a piece of 6/4. So that's why crown moldings are usually made sprung to save the lumber. We have the proper miter cut because we have our stop set up, ceiling projection away from the fence. So we have a proper miter cut and we're going to cope to that line. And then we know we're going to have the proper depth to our cope because the miter cut was correct. We can get into, how we cope and how much back clearance we put on it to make it fit, but let's just assume that we're coping correct with a little bit of back clearance and everything's right. So then the cope is going to fit. It should fit every time, but it's not necessarily going to fit correct if we don't put the first piece that's square cut up correctly. This piece has to put up with the proper ceiling projection in order for the cope that has the proper depth of cut to it to fit. So for 3 1/8 ceiling projection and a 3 1/8 cope depth, this molding needs to be 3 1/8 inches out from the hypothetical square corner. So if we look at this graphic, this is our hypothetical square corner. But if the wall has joint compound and everything else, it might actually be inside here or inside from the ceiling down. So we might have to try to measure from behind the sheetrock to get to where we're going to be. So we really can't do that. So what's the best way to set this first piece up? A lot of guys will measure the wall projection and they'll take the tape and they'll stick it up in the corner and they'll measure down 3 1/2 inches or whatever this wall projection is and put a mark. The problem with that is that let's say there's joint compound buildup, it's pushing your tape down farther than it's supposed to be. You're not at the hypothetical square corner. So now we're down the wall too far, we set the crown there, and in order to hit the ceiling we have to rock the crown up to hit the ceiling. So now we just changed our ceiling projection. Instead of 3 1/8, we might be at 3 inches. Then when we go to put our cope in, it's open an 1/8 inch on the top because we didn't get our first butt cut piece at the proper ceiling projection. So there's a couple of different ways to get this first piece up correct. The way I like the best is to use a coped piece. And I like the piece to be about 2 foot long. So our square cut piece is up and we need to locate it in the correct position. If we use a coped piece, the coped piece is going to hold that piece at 3 1/8 ceiling projection because that's the depth of our cope. So a coped piece is going to locate that crown exactly where it has to go. And because it's 2 foot long, it's going to take into account if the ceiling going out that direction is off a little bit. Another way to do it is to use a block piece of wood. I like to do about 18 inches long or so, and we cut the wall and the ceiling projection. We cut a notch in the end. And what this is going to do, it's going to hold the crown at the proper wall and ceiling projection. The problem with it is that it's spot location. So wherever you put this, it's going to give you the proper wall and ceiling location at that spot. So this is good to put a 12-foot piece up and put this in the middle of the 12-foot run. It's going to hold your crown, and then you can adjust the ends depending on where they need to go. The problem is that if the ceiling is going uphill on the piece that's going to be coming in, this isn't going to take into account what's happening in the ceiling over here. That's why the 2-foot cope piece is going to do that. It's going to take into the ceiling account. If it's going up or down over here, that's going to take it into account. And as you can see, it's going to rotate this crown up and down depending on if your ceiling's going up or down. Another way is to take that piece that we ripped at 3 1/8 to set our chop saw stop, our crown stop. I glued a piece of the crown molding on it, the proper wall and ceiling projection, and I lopped off the corner in the back. Now I can take this and slide it up the wall until it hits the ceiling, and I can mark the top or the bottom. And this is going to take into account if the ceiling is going uphill or downhill, because depending on where the ceiling is, this is going to go up and it's going to hit the ceiling and give us the proper wall and ceiling projection. But again, this won't take into account if the other section is going up or downhill. So in summary, we can see the 45-degree miter cut is all important. It produces the cope line and sets the depth of our cope. Because of the geometry of a 45-degree right triangle and miter cut, the thickness of our baseboard sets and equals the depth of our cope. Same holds true for a sprung crown, where the ceiling projection is the same as the thickness, and then the depth of the miter cut and cope equals the ceiling projection. So on crown copes, use a crown stop to cut your miters. Measure your miter cut and make sure it equals your ceiling projection. Cope to the line with just a little back clearance. Set the first square cut piece you are coping into at the proper ceiling projection, and all of your copes will fit first time, every time. And it all works because of the simple 45-degree right triangle. Thanks for watching.